So in this video I'll be solving some circuit problems. So these ones we'll be working with AC. So I'm using a different system, so my pen will be a problem. So this is an AC circuit that we're working with. I can't even, okay, cool. So the first question that we'll be looking at is this question here: calculate the equivalent impedance. So we have to notice that this thing and this one are in series, but they are in parallel with this one. So I think we can just say 1 over impedance of R1 plus impedance of C2 plus 1 over impedance of R1, that all inverse, plus impedance of C1. Then we can get Z total. So I hope that makes sense. Then if that works very well, then we can try to grab our calculator. So to continue, we'll need some few basic things. We'll need to have some impedance for C1 calculated and impedance for the rest of the stuff calculated. So if I can look at let me try to compute impedance for C1, which is going to be 1 all over J, CWJ, which if I use the calculator, what do I get after? Let me bring my calculator back. So it's going to be 1 all over, what is my W was given here on the question is given to be 6.67 kilo, and then what is my capacitance of which is 30 times 10 negative 9 for nano. And then what do I have? Oh, I should have put my calculator into complex mode, so I think I have say setup, and then here you see here number 2 it's written complex. Now it's in complex. Cool. 1 all over, I'm repeating the same thing because I made a mistake in the first one. 6.67 times 10 kilo, 3 open, then capacitance is what is it, 30, nano is negative 9, close, and then we know we put I for J. So if I compute this, I get this number. Then I want to say shift store this number at A. So now that equals to 499. I don't know what was there, but let me just point 0, and then it was complex. I started at A. Cool. Let's try it for impedance for C2. We're doing actually the same thing. Just going to get our calculator again. Where is it? Cool. So the only thing that we are doing now, we go back on our problem, but we're going to change the data to 15 because impedance for C2 is 15. I think 15, like that, and then we get impedance for C2. Then shift store that answer, it's B. Then we go back here, it's going to be the same formula, but now I'm going to get, this was negative also, negative 999.9 J. It was stored at B. I think you can see that at B. Cool. So now we can plug all these numbers in here. 1 all over X, impedance for R, it's just exactly, this would be R2, I think. It's going to be 1 over R2 is like 1000. Oh, sorry, I'm putting over, erase. Okay, it's going to be 1000 plus impedance of C2. Let me just put B here. Remember on our answer we should be putting that thing, but I started my calculator on B. 1 over R1 here. See on my R1 here, it's given by it's my R1. Where is R1? R1 is given by 3000. So I can go back to my pen. So 3000 and then this is all flipped, and then impedance for C1, I think I got it and I saved it A. Let me put A here. Then I'm going to get my Z total. With that being said, then I can go back, bring my calculator again, of which okay, now I have it. I have all my numbers. I'm going to open brackets fraction 1 all over 1000 plus B. I've saved it at B, alpha B. Then I move out, and then I'm adding 1 all over what is the number now? It's going to be 1000, I think. Oh no, it's a 3000 now. 3000, then close, then everything is flipped. Then I'm adding impedance on C1, of which is alpha A. Then I get my answer here. My answer is in polar form. I don't really like answers in polar form, so I'm just going to say shift complex number 3, making it that was rectangular, making it polar. Okay, cool. Then I'm getting this 1855 for negative 49. 1355 negative 49. Let me shift store the answer at C. Cool. So this answer is at C. I think it was 1355. I'm not going to worry about putting it very correct because obviously I have it stored. Cool. So now we have the total impedance there. Then we'll try to find the voltage across R1. Where is R1? Okay, cool. Voltage across R1. That's nice. If you want to find voltage across R1, we can just put the impedance. Okay, let me say this thing was clear. I'll try to clear it out. So what are you going to do? You're going to have what is the impedance? What is the voltage drop across this node from here straight to the ground? If you remember, this is the ground. So whatever V that we get here will be the V across R1. So what is the impedance on the branch? Impedance of the branch on the branch will be 1 all over what is happening? 1 all over R1 plus 1 all over R2 plus impedance of C2. That is inverse because that we're adding parallel things, all over Z total, of which we have it already computed, and then multiply by the voltage in the source. Voltage in the source, I think we're going to have that is 5 volt divided by root 2, because you're trying to, this is max VM here, we're trying to take it back to RMS. So now the calculator will come again and do all the magic for us. Now the calculator is back. I have everything saved here. Okay, let's look what the calculator do for us. Okay, first of all, I have a fraction open. The fraction I'll have 1 all over R1. What is R1? It's 3000. I hope I didn't make any mistake. Plus 1 all over R2. I think that's 1000. Plus impedance of C2. We have its impedance there. It is C2 is stored at B. Let me just say alpha B. Close, this thing is flipped upside down all over Z total, and Z total was saved at, let me look here, I think I had it at C. Then I can just put C, alpha C, close. Then remember, multiplying all this thing by 5 all over root 2 to make it RMS. Then I say, what is my answer? You tell me. Then I don't like answers like this. I'm going to say shift complex. I like them with magnitude. And then it's look like this. And then change them to make it look like that. Then let me shift store answer at C. Okay. Shift back where it is. I think I have it. Oh, I just have it on C, and then it's override the other one. Okay, cool. Doesn't matter. I'll remember the answer. Okay, then 3. Check the answer. 2.68 and 18. 2.68 and 18. 2.68 and 18 degrees. That is going to be the voltage across R1. Okay, remember this was 18, so I don't know how I got the 0 here, but now you know the correct answer. Okay, cool. So let's try to move on with our question. Okay, so we are done with I think this was total, so we've done with 3.1. We're also done with 3.2. Now concern will be 3.3. What is 3.3 saying exactly? It's saying calculate the voltage across C2. Let's go back. Where is C2? We want a voltage across here, but we know that the voltage supplied on these nodes to the ground, we know it. So that would be nice. So we can solve this now. I think we can say voltage at C2 is going to equal, so I'm going to do voltage divider as much as I did. Where did I use it? I think I used voltage divider here. I'm going to do voltage divider again. So if I do it, it's going to be the impedance of XC2 all over the total impedance on that branch, of which is going to be R2 plus impedance of C2 multiplied by the voltage at R1, because now we are dividing the voltage that is supplied here, of which is this one here. So because I lost my answers somewhere, my answers will be inaccurate because of that thing that I made on the mistake on my calculator. So now impedance at C2 was saved to be, I think I saved it B, all over R2 is going to be 1000 plus impedance at that was C2. Impedance at C2 is also at B multiplied by this one. I think I saved it somewhere. I don't know. I think I saved it C. Let me just write it as it is for copying reasons. 1.8. Then if I put this in my machine again, I should get the same correct answer. Let me say I shift stir this answer at D for some reason. Okay, so I'm going to say whatever the answer that I have at D multiplied by the alpha B all over 100 plus alpha B. It's in rectangular. You can record it to rectangular, but I just like this one with no reason. And then I have now my it's going to be negative 26. Okay, shift store that's answer at E. Okay, so it's going to be, the correct answer is going to be, from the calculator I think I can round it off to be, I think I can make 1.90 open negative 26.57 degrees, and I start this answer at E if I remember very well. So the next thing will be current at C1, current at C2. Okay, we are winning so far. We want current on C1. Okay, we could just use Ohm's law, right? You know, V, that's what I call it, VIR. Then we want current. It's going to be, current is going to be equals to V all over impedance. Let me just say impedance. Okay, so it's C1. So voltage across C1, we already, do we have voltage across C1? Yes, we do we? Okay, let me just start with R1 because I know everything with R1. Where is R1? Yeah, let me start with R1 because my brain is responding when I'm talking about R1. Okay, V at R1, I know V at R1 is this one, 2.68 open 18. It might not be too accurate, but you'll get the idea. All of our impedance of R1 is given to be 3000. ohms. Then I could just punch this in the calculator. Okay, I can just get my thingy. Okay, so I'm looking for current across R1. What I'm going to have whatever the voltage at R1. I think I have it at E. Let me check what is on E. Where I recorded it. It's not it. It's not there. Let me try C, alpha C. Complex 3. Yeah, it's exactly at C. So I'm going to say alpha C all over resistance. I think this is it, 3000. Then I punch my calculator. Then I'll say shift complex 3. Not answer. Then my answer will be something like this. I hope I didn't make any mistake, but it's 18.4. Okay, I can just write those commas like that. Shift throw the answer at M. So I have this answer at M for reference. So I can just what is my answer if I remember very well? I think it's R1 number I got now was something for him, just write it in commas, 0 0.0, how many zeros? 3 plus 4 there, 8 5. Did I change? I think if I change it shouldn't be like that. If my calculator is here, I'm just lazy to go back and check the answer. I think it should be 0.002 open. No, why I'm forgetting this thing I just wrote now. Then it should be 0 0 comma 0 3 zeros 9 if I'm rounding off, and I'll have that 18.4. Remember, it is in amperes. So I could continue and do the rest of the questions here. I feel like it will be just waste of time, but I think now you get the logic, how you use your calculator. I think that's the most important part. Other than that, I'm just going to make a short video on how I use my calculator here in the end, because I think that's what makes everything easier for me. Okay, cool. Most important things, let me just say shift off. Let me say I could shut my calculator off. Shift clear all. This is my calculator. The most important part, if you're working with these, set up, make it too complex. If it's in complex, you can actually add anything that you want. Let me say it was angle 30, right? All okay, cool. Should have started with divide all to angle 30, maybe out of all over 2i plus 3. You see, you can do all the complex math, then you get to every form. To change form, it is shift complex 3. For power problems, let me say you can also do conjugate. Let me say this is my answer. This is it. I can shift store it at A. I can just say shift complex and then 2. I can do the conjugate of A, then it will give me the conjugate of A. Or maybe I want only the argument of A. Easy if it also say complex argument is here, right? It's at 1. Argument of what? Of alpha A. So I think these are one of the most important functions you need to know on how to use your calculator. Other than that, I don't think there's anything that can trouble you, as long as you know voltage divider. I think it's important. Voltage where you want is going to equals to the impedance where you want all over sum of the impedance multiplied by the voltage supplied. Let me just say voltage source. I think that would be nice to remember. Okay, then what else I think you should remember? I think you should remember this one. I know it's easy. Summing parallel impedances will be 1 all over impedance 1 plus 1 all over impedance 2. Remember, you flip them up. On the other side, you need to remember this. These are the basics you need if you're preparing for the test. What else can can I remember that you should remember. With this, I think you can tackle a test. Also, you can forget V is equals to IR. You can also forget that let me remember this one. It's D S T. I'm trying to remember something. If you want time, it's going to equals to distance, of which is 2 pi all over speed, of which is omega. Or you can use this one, or I'm trying to take the formula I was trying to remember is frequency formula, of which is going to be omega all over 2 pi. You need to remember this formula, obviously. Also, you need to remember that impedance of an inductor is equals to W L J, and impedance of a capacitor is going to equals to W C J, but will be in the bottom. Remember that omega could equals to 2 pi frequency. So if you remember those, I think you are really good for a test. What else can I remember? With that, I think you know everything ready for the test. So thank you. Please don't forget to like and subscribe, and ask for request videos if you have something that you want me to work on. Thank you.